Hi everyone, so today I'll be going through the matrices section of the 2019. I'll be going through the exam 1. So question 1, consider the following four matrix expressions. How many of these four matrix expressions are defined? So all of these matrix expressions show addition. So basically if you want to add matrices together, you have to have the same number of rows and columns. So for example, if we look at the first one, it has 2 rows and 2 columns and 1 column. And the second matrix also has 2 rows and 1 column. So 2 and 1. They have the same order, so therefore this matrix expression is defined. Let's take a look at the second one. 2 rows and 1 column. And that has 2 rows and 2 columns. These matrices do not have the same order, therefore it's not defined. Let's take a look at this one. 2 rows and 2 columns. And this one, 2 rows and 1 column. Matrices do not have the same order, therefore they're not defined. Let's take a look at this one. 2 rows and 2 columns. And the second matrix also has 2 rows and 2 columns. Therefore it's defined. So how many of these four matrix expressions are defined? We have 2 matrix expressions that are defined. So C is the correct answer. Question 2. There are 2 rides called the Big Dipper and the Terror Train at a carnival. The cost in dollars for a child to ride on each ride is shown in the table below. 6 children ride once only on the Big Dipper and once only on the Terror Train. The total cost of rides in dollars for these 6 children can be determined by which of the following calculations. So we got to determine the total cost of the rides, and it only gives us matrix expressions in the as multiple choice answers. So to do this question, we know that there's 6 children that ride on the Big Dipper and Terror Train. So let's just say that would be our matrix for Big Dipper and Terror Train. And the total cost would be found by multiplying a cost matrix. So we can form a cost matrix for the Big Dipper and Terror Train like that. Big Dipper and Terror Train. If you multiply that, that will give you a 1-by-1 matrix that has the total cost. But that's one matrix expression we have that could give us a total cost for the total cost of the rides for the 6 children. It could also be expressed like this, 7, 8 multiplied by 6, 6, which would also give us the total cost for the rides of the 6 children. So either one of these matrix expressions would give us the total cost for these 6 children. And you notice that the total cost has to produce a 1-by-1 matrix, which both of these matrix expressions would. So let's just take a look at the options we have. We have we have this expression over here, which is what we had up here. So therefore D is the correct answer, which would give us the total cost of the rides for the 6 children. Question 3. Consider the matrix P where P equals the following matrix. The elements in row I and column J of matrix P is Pij. The elements in matrix P are determined by the rule. So you should know that the general rule for a matrix is a coefficient in front of the value of I, a coefficient of I plus a coefficient of J plus a constant would give you the general rule. So you look here at the matrix, you first look at the difference between the first row and the second column. So if we're moving down, you see that it increases from an increase from 3 to 5 is an increase of 2. So an increase of 2 from 3 to 5. So write plus 2i, because I represents the increase in the value of the rows. And then you look at the columns from left to right, and you see that it decreases by 1 each time. So write minus 1j. Now you sub that into the rule. We wrote over here plus 2i, so you write 2i. And we wrote over here minus 1j, because it decreases as you move across the rows, as you move across the column, sorry. So you write minus j plus a constant, which we need to determine. So to determine the constant, basically all you need to do is sub the values of 1, 2, 3 for the column and 1, 2. So let's try 1 and 1 for example. 2, 1 for the element in row 1, column 1, minus 1 plus a constant, which we don't know yet. So that would give us 2 minus 1 plus a constant, which would give us 1 plus a constant. So the value in row 1, column 1 is 3. So far we got 1. So to make it 3, we just plus 2. So our constant would be 2. But now let's try that. Now let's try that for row 1, column 2. So if we said our rule is 2i minus j plus 2 as we determined for our constant, we'll try row 1 and column 2. So row 1 is 2 and 1 minus value for j is the column. We're using column 2, so 2 plus 2. So 2 minus 2 plus 2, that would give you 2. And the value in the element in row 1, column 2 is 2. So therefore we know that our rule is correct. So therefore the rule is 2i minus j plus 2. You look at the multiple choice options, 2i minus j plus 2. Therefore E is the correct option. Question 4. Stella completed a multiple choice test that had 10 questions. Each question had 5 possible answers, A, B, C, D, and E. For question number 1, Stella chose the answer E. Stella chose each of the 9 remaining answers in order by the following transition matrix T below. What answer did Stella choose for question number 6? So we know in the question it says Stella chose E for question number 1. So if she chose E for question number 1, we can determine what she chose for question number 6 using the following transition matrix. So if we look at the transition matrix, we start off at E. You go down, the transition matrix says that her next answer would be C. So you write C. Then you go up to the column and you look for C. C, you go to the row where the 1 is. The row is A, so A would have been your next question. Go to column A. Look for the 1 is where it is in the row. It's in row D. So your next question would have been D. From D, you go to the column. Look for the 1 where the 1 is. You look at it in the row. B would have been her next answer. So that's her first question. That's the second question. That's the third question. That's the fourth question. That's the fifth question. So her 6th question would have been her next one. So from B, you go to column B. You go down to where the 1 is. So her next question would have been E. So therefore, Stella would have chose multiple choice option E for question number 6. So therefore, E is the correct answer. Question 5. Which one of the following systems of simultaneous linear equations best represents the matrix equation above? So basically, first step is to enter this matrix multiplication onto your calculator. So you enter a 4x4 matrix first of all. And number of rows is 4, number of columns is also 4. Hit enter, and you just enter the matrix we have given in the question. So I'll get the matrix up again. So 2, 2, 0, 2, 2, 2, 0, 2, 0, negative 2, 0, negative 2, 0, negative 2, 0, negative 2. So times by this 4x1 matrix over here with all the variables. 4x1. V, W, X, and Y. So if you multiply this 4x4 by the 4x1, you'll get this following matrix over here. So we'll write that matrix over here, which is 2v plus 2w minus 2y. 2v minus 2x, 2w minus 2y, and the last one is 2v plus 2w minus 2x, which equals 2, 6, negative 8, and 4. So if we express that as just equations, that means that 2v plus 2w minus 2y equals 2, and it means 2v minus 2 equals 6, 2w minus 2y equals negative a, and 2v plus 2w minus 2x equals 4. So you just look for one of the multiple choice options that has these following equations. B, 2v plus 2w minus 2y is 2, 2v minus 2x equals 6, 2w minus 2y equals negative 8, 2v plus 2w minus 2x equals 4. So that has the same equations as what we wrote down over here. So therefore B is the correct answer. Question 6. A water park is open from 9 a.m. till 5 p.m. There are 3 activities: a pool, the slide, and the water jets. At the water park, children have been found to change their activity at the water park each half hour, as shown in the transition matrix below. A group of children have come to the water park for the whole day. The percentage of these children who are expected to be at the slide at closing time is closest to. So the first step is to determine the number of half hours from opening time to closing time, because we know that the children stay the whole day. So the number of half hours would be 16. And to do this, you just determine the number of hours from 9 a.m. to 5 p.m., which is 8 hours. And then you just multiply that by 2 to determine the number of half hours, which would give you 16. So if you raise the transition matrix T over here to the power of 16, it will give you the following matrix over here. And as you can see, the numbers in each row are approximately the same. They're very, very close. They're not the same, but they're very, very close. So that suggests that the steady state matrix would have been reached after 16.5 hours. So basically this suggests that 0.14 is a proportion of the total number of children that will be at the slide at closing time. So if 0.14 is a proportion, then you convert that to a percent. You times that by 100, and that'll give you 14%, which is of course rounded to the nearest percentage. Because if you get the exact value from your calculator, it might be like 13.79, so it might be a few decimal places off. So if you round it to the nearest whole number, that would give you like 14%. So therefore, A would be a correct answer. Question 7. The communication matrix below shows the direct paths by which messages can be sent between 2 people in a group of 6 people, U to Z. A 1 in the matrix shows that the person named in that row could send a message directly to the person named in that column. For example, the 1 in row 4, column 2 shows that X can send a message directly to V. In how many ways can Y send a message to In how many ways can Y get a message to W by sending it directly to another person? So Y can communicate directly to W, X, and Z. We want to know in how many ways Y can send a message to W by sending it to another person. So we know Y can send it to W, but we want to find out how many people Y can send to another person which communicate to W. So if we look at X can, if we go to X, so if we look at X over here, X cannot send a message to W because there is a 0 in that column. So therefore, X cannot communicate to W. Y can communicate to Z. So let's see if Z can communicate with W. Z to W. There's also 0 there. So therefore, Z cannot communicate with W. So therefore, how many ways can Y get a message to W by sending it to another person? Basically, Y cannot send a message to W by sending it to any other person. So therefore, 0. Question 8. An airline parks all of its planes at Sydney Airport or Melbourne Airport overnight. The transition diagram below shows the change in the location of planes from night to night. There are always M planes parked at Melbourne Airport, and there are always S planes parked at Sydney Airport. Of the planes parked at Melbourne Airport on Tuesday night, 12 had been parked on Sydney Airport on Monday night. How many planes does the airline have? So we know that the steady state would have been reached because there are always M planes at Melbourne Airport and S planes at Sydney Airport. So basically, the question is telling us that each night there's always going to be the same number of planes at Melbourne Airport and the same number of planes at Sydney Airport. So the question says, of the planes parked at Melbourne Airport on Tuesday night, so this was Tuesday and this was Monday, of the planes parked at Melbourne Airport on Tuesday night, 12 had been parked at Sydney Airport on Monday night. So basically the question suggests that 48% of the planes at Sydney Airport on Monday night would have been moved to Melbourne Airport on Tuesday night. So it's saying that 12 parked at Sydney Airport on Monday night. 12 were parked at Sydney Airport on Monday night, and the 12 of these planes parked at Sydney Airport on Monday night moved to Melbourne Airport on Tuesday night. So that's suggesting that 48% of the planes at Sydney Airport would have been 12. So 0.48 times the total number of planes at Sydney Airport would be 12. So if you do that on your calculator, you'll find the number of planes at Sydney Airport each night. 12 divided by 0.48, which gives you 25. So we know there's 25 planes at So we know there are 25 planes at Sydney Airport each night. So if there are 12 planes moving from Sydney to Melbourne each night, then we would know, since the steady state matrix has been reached, that the number of planes moving from Melbourne to Sydney would be 12 as well. So if we do 0.2 times the number of planes at Melbourne Airport, that would also give us 12. So basically that just suggests that 20% of the planes parked at Melbourne Airport each night so this basically suggests that 20% of the planes parked at Melbourne Airport each night would be 12. So this basically suggests that 20% of the planes parked at Melbourne Airport one night will move to Sydney Airport the next night. So if you do this on your calculator, you do 12 divided by 0.2 would give you 60. So now we've determined the number of planes at each airport each night. So we know there are 60 planes at Melbourne Airport each night and 25 planes at Melbourne Airport each night. So if you add that together, that'll give you the total number of planes that the airline has. So therefore E is the correct answer.